18, 17. These are finals. So the 16th, our last day of ask questions a lot. Today we're going to get into 9.5. Tomorrow we'll do a little bit of 9.5, the crazier stuff. Friday we'll do 9.6. Monday might be a little 9.6 slash if we have to finish that out, because 9.6 can be a little bit weird if you're not careful with it. So it might take us an extra day. So tentatively, as of right now, I have us reviewing out and testing on Chapter 9 next Wednesday. So a week from today we'll be done. We have 2 sections to go. These are kind of the ones these last 2 sections are the ones that take the longest to get through. Next Thursday, I completely had forgotten about this, but next Thursday is a half day. So we're going to start doing a bunch of reviews here with like the packets and stuff. And just review and review. What I plan on trying to do is, when it gets close to the test for Chapter 9 in a week, I'm going to try to make sure that we'll go over the stuff that we talked about in class, as well as do all the problems that I've given you so far in that little review sheet, or the other review stuff that I'll have for you. We'll kind of work through those on the packet chunk as we get going through it. That way we have some stuff to work through. Then, excuse me, going into finals with yours being on the Friday just kind of stinks, but just going to have that extra break. That's why it's so nice that they approved the air conditioning thing for Lincoln. So hopefully it all goes according to plan. They'll have the air conditioning installed in time for the school year to start, and then next year we'll start about basically 5 days earlier. And your finals next year will be prior to break. Great. Now let's have to wait out and do all this other stuff. So that's kind of what we're looking at over the course of the next couple of weeks. So you guys are knowing, and we'll go from there. You guys have a good break? Sorry. I'm sorry. Hopefully that your non-break will be better. How about an air 5 then? There you go. It's better now. All right, you get a real one. All right, come on. Oh, that was a bad one. Let's go. You're annoying. All right, so let's talk about this. That was great. So let's talk about what we're looking at in terms of what are going to be adding, subtracting complex fractions. Last week we talked, or last couple weeks ago, we talked a bunch about multiplying and dividing. And when we multiply and divide these rational expressions, basically what we were doing each and every time is that we would factor, and then see what would simplify out and we would rewrite. Well, when you add stuff, when we multiplied and divided, right, it didn't matter about denominators because it didn't have any combination to any fault to the problem at all. You just kind of multiplied straight across. When you divide, you flip the second fraction, you multiply straight across. But when you're adding fractions, what do you have to have? You got to have a common denominator. So what we've done in the past is that we've worked with problems that we started out very simple. 2/3 plus 1/2. And what we would talk about is we would worry about what's called, we find a least common denominator. A least common denominator is the next smallest number that both a 3 and a 2 go into. Now, there's a couple of ways that you would do that. One of the ways that you would do that is you would prime factor the 3 and the 2. Well, is 3 prime? Is 2 prime? So since those two guys are already prime, all you have to do is just multiply them together, which means the common denominator here is going to be a 3 times a 2. Right. Now, if I'm looking at them in terms of the fractions themselves, the first fraction, the one on the left, the 2/3, has a 3 in the denominator, but it does not have the 2. So I have to multiply the top one by a 2. This guy has the 2, it's missing the 3. And then I would simplify myself out. I get 4 plus 3 is 7. I get 7/6. Now, does that change any then, if by chance your denominators aren't already prime? No, it doesn't. For example, if I have, let's say, 4/15, and I want to subtract 2/3. 15 is a, you guys know the difference between a composite and a prime? All right. 15 is a composite number. It means it's made up of multiple prime numbers. 15 can factor out to be what? Two numbers, two prime numbers. 5 and 3. So I can write that as a 5 times 3. Do you guys remember doing factor trees? It's not a bad thing to look at every once in a while with this stuff, because now if I look at those two fractions, what number do those two fractions have in common in their denominators? The 3's. And I know I'm kind of oversimplifying this for right now, but notice they both have a 3. And then what else is left? 5. So my common denominator is going to be 3 times 5. In other words, 15. Fraction on the left, though, it has both the 3 and the 5, so do I have to multiply the 4 by it? No. Fraction on the right needs to be multiplied by 5. So we get 4 minus 10 over 15, negative 6 15ths, and then, excuse me, then we can simplify that, right? Yeah, and you can simplify that down to being what? 3/5, negative 3/5? 2/5. Yep, math is hard. And that's what we do. Okay? Again, this isn't anything you haven't seen or you haven't done before. It's just, oh yeah, I'm going to do a little extra stuff here and there. Okay? Now, does any of that, you think any of that's going to change when we throw in variables and terms? You're right. So I'm looking at 4 over 3x plus 5 over 3x. If I have 4 over 3x plus 5 over 3x, yeah. Do they have a common denominator? Yeah. Just like it happened in the past. If you have a common denominator, then you just write it down, and you just combine your like terms in the numerator. Well, here, they have the 3x, and you get 4 plus 5, which is 9. Now you simplify. 9 over 3x simplifies out to be what? X. Again, this is nothing that seems so far-fetched out of the ordinary. You may have done stuff with very simple monomials in the past, but you may not have done things as we start getting a little more complicated. You might not have seen those, but you're still using the same basic properties and principles. Does anything change when you deal with a subtraction problem? Absolutely nothing. Nothing changes with the subtraction then. You still have to ask yourself, do you have a common denominator? If not, how do I get one? And in this case, we have a common denominator. It's x plus 3, so it's pretty quick. And then in the numerator, what do I just write? Exactly. I have the x plus 3. Oops. And I'm done. Can I simplify the x's out? No, because of the addition or subtraction signs. You cannot simplify over addition. It makes people sad. Okay. Again, exactly. Okay. Yeah. Gee, what do you think we have to do? I kind of left a big giant hint on there about what you'd have to do with something like this. So write it out and we'll talk about what we have to do here. You have 5 over 6x squared plus x over 4x squared minus 12x. But if I want to add these things, just like we've done in the past, more often than not, what you want to do is factor stuff so that way it's written out in its specific terms. Because remember, every time you factor something out, you're basically factoring it in terms of primes. You're taking a composite statement, 4x squared minus 12x, and you're taking out the prime parts of it. What do they have in common? Well, they have a 4 and an x. You can bring that stuff out. Okay? It's the idea of breaking a 6 into what times what. Yeah, 2 times 3, very good. You know, it's little things like that. It's how do you break these things apart? So in this case, as we get more complicated, we have 5, 2 times 3. I'm really going to oversimplify this so you guys can see what we're doing here. All I did was I wrote the term 6x squared as a product of prime numbers. Not only did I write it in terms of prime numbers, but I broke apart the squared part. X squared just means x times x. That's just why I wrote it like that. Okay. On the other hand, then, you guys figure that you have to take out a 4x and you get an x minus 3. You okay with that? What can I rewrite the 4 as? 2 times 2. So what I'm doing here is I'm rewriting everything in terms of prime numbers and terms. Now, if I look at my second fraction, I have x divided by 2 times 2 times x times the quantity x minus 3. Did I do anything with that? I can simplify the x's there. The reason that I can simplify the x's there is because see how everything's listed up in terms of multiplication? And it doesn't matter that I've got that parentheses of the x minus 3 because the parentheses are being multiplied by the x, the 2, and the 2. So it's its own term that you could, in essence, simplify itself out. So what happens when you have x divided by x? It's a 1, okay? So if I simplify that in terms of 1, does this portion here, does it float up? Is it wearing a life jacket? No. It's man overboard. It's on the denominator. What's now in the numerator? 1. It's a mistake that you guys will tend to make. It's a very, very common mistake for students, once something gets simplified out as 1 in the numerator, for you guys to rewrite the denominator without the 1. Remember, it's not wearing a flotation device. It's man overboard, and they're stuck floating away from the door, and Jack dies. Whose name was Jack, right? Yes. But your heart will go on. Spoiler alert.
Yeah.
And
like they could.
that movie was about 3 hours too long. Anyway, so back to this.
I mean, I still cry.
That's it.
I still cried.
All right. Sorry, I didn't mean to get sidetracked to death and mayhem. Denominators. I have these things written out as prime factors in the denominators. What do those two denominators have in common? A 2. They only have a 2 in common. Here's a trick that I'm going to show you guys. When I see that they have something in common, notice I underline it, and then I write it down to my new fraction I'm creating, which means these guys are now accounted for. Is there anything else that they have in common? 3, that's the term. X times x, those are 1 terms. So that means now I write down what's left. I've taken out the common part, the 2's. What's left? I have a 3 2, and an x minus 3. Now, over time, you guys probably would have just said, all right, well, I know it's a 6 and I know it's a 4. The next common number they'd have to have with 6 and 4 is going to be what? 12. Very good. I thought, sorry. What's 2 times 3 times 2? Okay. I'm just writing it out in terms of prime numbers because I'm just kind of oversimplifying it out. So this denominator that they have in common then is 12x squared x minus 3. That'll be my common denominator. Denominators, I'm never going to ask you guys to multiply out. There's usually no reason to. From time to time, there might be when you combine like terms and stuff like that, you might have all your terms might be even. You might be able to factor out a 2 or maybe a 3. But more often than not, you don't need to worry about it. So now I go back to my numerators. My numerators were a 5 and a 1. If I'm looking at my numerators, my first numerator on the left had a 2, a 3, and an x squared. So it had a 2, a 3, and the x squared. What was it missing? The 2 and the x minus 3. So it's going to be 5 times the quantity 2 x minus 3. Fraction on the right had the 2 times 2 and the x minus 3. It was missing the x squared. Okay. It's a matter of looking back and forth. What is it missing? What does it have? And by writing it out in terms of primes, you're just kind of looking at it, going back and forth. But honestly, if it's a 6 and a 4, you probably could have figured it out. All right, it's got to go become a 12. What do I have to multiply it by? I got to multiply it by a 2. How do I turn a 6 into a 12 and multiply by 2? How do I turn a 4 into a 12 and multiply it by 3? And so on. Things like that. You'll probably be able to figure that out. Numerators, I always simplify. What's 5 times 2? So I'm going to have a 10 times the quantity x minus 3, which gives me 10x minus 30 plus a 3x squared. And just because I'm weird like that, I'm going to write it as a descending order and I get my final answer. 3x squared plus 10x minus 30 all over 12x squared times x minus the quantity x minus 30. And that's my final answer. Yes, ma'am? Yeah. I'm sorry, to the what? The 1 by 2?
Yeah.
Oh, if you look on the right hand, on this right hand fraction here, see how it's 1 over 2 times 2 x minus 3? So it already has the 2, and the x minus 3, it's in the 3x squared portion. Right? And that's where we go from there. You're done. You don't have to factor that. You don't have to worry about it. And because what times 1 is negative 90, and add together to get 10? Usually nothing.
No.
Okay. All right. Again, it's not that it's horribly complicated. It takes a minute or so to go through. All right. All right. So we just did a complex one. Let's go backwards and do an easy one. All right. We did a difficult one. What's that? We will. We will. Don't worry. So you have 7 over 5x plus 8 over 3x. Should be pretty quick here. What do they both have in common? What do they both have in common? X. They both have the x in common, but then you have a 5 times 3. 5 and 3 are both primes. I'm just going to write it down separately. If you want to write it as 15, that's fine. I'm going to write it out the long form just because it only takes a second. Because it also will help me to recognize, well, there's already a 5x here. What's it missing? Devin, you throw, okay, you've thrown something at me? So it's got the 5 and the x, it needs a 3. This side has a 3 and the x, and it's missing the 9. So we get, what is it, 21 and 40, which is 61. So my final answer would be 61 over 15x. And I'm done. Okay. What's that? But you see how it bounces back and forth, being kind of the same process each and every time. Now, do they get messier? Sure. But if you keep factoring and looking for terms, it's the same idea. For example, remember when we did multiplying and dividing? When we did multiplying and dividing, you had trinomials and things that were written in higher degree powers. My suggestion to you guys was always to, as you write it down, factor it. Do the same thing. Okay? Do the same thing. As you're writing this problem down, factor it as you're going. The reason that I'm saying the suggestion that I do that is so that it's easier later. You'll save yourself, a line or two in your notebooks. Okay? So as I'm writing this out, I have x plus 1 over the x squared plus 4x plus 4, which means I need to factor that denominator. What times what is 4? They add together to get 4 and 2. So the way I would do is this. I'd write down x plus 1 over x plus 2, x plus 2. X squared minus 4. What does that factor mean? Good. What do those two fractions have in common for their denominators? They both have an x plus 2. They both have one x plus 2. What's left? That's not underlined. Yeah, exactly. You're left with an x plus 2, an x minus 2. And now you have a common denominator as 3 specific terms. Don't multiply them out. Never multiply out a denominator. That's just silly. But the fraction on the left has x plus 2, x plus 2. What's it missing? It's missing the x minus 2. So I get an Now, this symbol means what? That symbol means subtract. Now, obviously, as you're going through this, you're going to have to subtract. Well, this has an x minus 2 and x plus 2. What's it missing? It's missing another plus. You're going to have to subtract the quantity 2 times the x plus 2. What's going to happen here is whenever you have subtraction problems, you have multiple terms, when you go to subtract them, you have to remember that you're distributing that negative everything. That's where you guys are screwed up. Yes, sir? Yeah. Again, the reason being is because see how they have one in common? We wrote it down. What was left? X minus 2 and x plus 2. It's the same basic idea of saying that if you have 1/4 minus 1/6. 1/4 can be written as 1 over 2 times 2. 1/6 is 2 times 3. What do they have in common? The 2 and the 2. What's left? 2 and a 3. What's 2 times 2 times? See where I'm going with that? Now all you have to do is FOIL, combine like terms of your numerator. Whoop. We have x squared minus 2x plus x minus 2 minus 2x minus 4 all over 2. Okay? Which gives me x squared minus 2x minus 2x plus x is -2, -4. And you're done. Quantity squared? Yes, absolutely. I was just about to say that. So I was about to say that first, never multiply out denominators. But if you do have repeated zeros, repeated terms, if you want to write it as the quantity x plus 2 squared, go right ahead. I'm not going to require that you do so, but if you want to say pencil lead, go for it. All right, that's fine. I have no problem with that. I have no problem with that at all. And that's what we're looking at here, guys. You can't factor that. What times what's negative 6 you add together to get negative 3. There's nothing left for you to do. Right? Not too terrible. So again, you were like looking for the a little more complicated because you got to factor a whole bunch of junk. But as you work yourself backwards, you're still doing that same idea of 2 times 2, 2 times 3. What do they have in common going off? Okay. You do this one. What's the common denominator going to be? Aren't these just terms? They're just terms, guys. They would, if it was 4x or 3x, it would be written like that. Since it's x plus 3 and x minus 4, those themselves are the specific terms. What's the fraction on the left missing? Missing the x plus 3. What's the fraction on the left missing? I'm sorry, on the right. Simplify out your numerator. We get x squared plus 3x minus 6x plus 24. As I'm simplifying each of these steps, do I need to continually rewrite my denominator? Is it okay that I don't? I mean, when I'm done with my answer, I'll write it, but do I have to do for each of these steps? Well, I'm not going to. Saving lead. There's lead in here. Well, these tips wear out. There you go. And you're done. Same process each time. Sure. Subtracting those, aren't I? Yes. What's the common denominator between a 4 and a 6? Think smaller. 12. What times 4 is 12? Bradley, it was a great question, but I'm trying to help you out here, man. 3. So it'd be a 1 times the 3. What do you multiply 6 by to get 12? 2. So even though I'm multiplying here, I'm still subtracting in between. So you get 3 minus 2, which is, it's the exact same thing, but yet it's a term as opposed to an integer. The process by which we set it up is identical. The fact that your term, instead of just being the common denominator being a 4, or a common denominator being 12, between a 4 and a 6, the common denominator there was x minus 4, x plus 3. So your initial thought of multiplying them together that would have worked if this was a 5 because they have nothing in common. That's why I do it. Does that help? Okay. Well, let's make this ugly.
No.
Let's make it ugly.
You said
What?
the crazy stuff.
No, we have time to do some crazy stuff today. Yeah, we do. Let's do some crazy stuff. You guys in your Y ambulance. Welcome to the way ambulance. The way ambulance. Thank you. Now, this is great. It was great. I've had this ambulance thing forever, and when we had the at Huntley now, they had those movable walls, and when we had those movable walls, my room was next door to Seb's. I don't know if you ever noticed it, myself and Seb were both kind of loud. So we would yell at each other all the time, but when if you fall asleep, I would play really loud music to wake you up, or I would do the ambulance, and he would always like, "What's on fire?" Anyway, you guys have actually done this problem before. That is called a complex fraction. In all honesty, it is the exact same problem as this. 2/3 divided by 1/5. That, no. Yeah. Now, what this is going to entail here, guys, what this is going to entail is both properties of division multiplication as well as common denominators with adding and subtracting. Now, if you had a complex fraction where it was 2/3 divided by 1/5, we don't like to work fractions vertically. We work fractions horizontally. This was the exact same thing as saying 2/3 divided by 1/5, which was the same thing as saying 2/3 times 5 over 1. So your answer would have been 10/3. So you, in essence, worked with the complex fraction as far as how the process to set it up goes works. What changes now is that when you have simplification and combining of like terms, you have to just break it apart into two separate problems. The complexity level doesn't change. It's just you're doing two steps to it. Okay? So let me move this down here and go through the example as far as, well, you have a numerator of 2 over x plus 2 and a denominator of 1 over x plus 2 plus 2 over x. I'm going to treat this as two separate addition problems that I have to try to, get a common denominator and go from that. The first numerator of 2 over x plus 2, is there anything I can do with that? No, there's nothing I can do. It's done, it's simplified, there's no other, I don't have to worry about common denominators, it's just one specific straight up fraction over fraction, or numerator over denominator, nothing left. But here, I need to get a common denominator to combine the quantity x plus 2 and then x. So remember, this x plus 2 is a term. Can't break it apart because of the addition. So does the quantity x plus 2 and the x, do they have anything in common? No. So that's the idea where if you have a 4 and a 5 in the denominator, you just multiply them together. So my common denominator here will be x times the x plus 2. Okay. Which then you go about the idea of, well, the fraction on the left has the x plus 2. What's it missing? It's missing the x. So you get a 1 times x here. The fraction on the right then is missing the x plus 2, so it's going to be 2 times the quantity. Okay. Again, don't multiply out denominators, but combine like terms in your numerator. You get x plus 2x plus 4, which is 3x plus 4 over x times x plus 2. Everybody okay with me on that? Now, the other portion of this, the 2 over x plus 2, just moves along. So now I have this vertical fraction, something divided by something, that I'm going to rewrite horizontally so I can actually map it. And instead of dividing by a fraction, I multiply by its reciprocal. And look at that. It's the same thing we were doing a couple of weeks ago, wasn't it? What happens? You multiply straight across, but what can I do since I'm multiplying now? What can I simplify? Gives you an answer of 2x, 3x plus. It's a lot of work, but really, if you look at it, it's just two problems mixed into one. You're simplifying as you're going through, and then you just flip it at the very end. One suggestion, take the 2 minutes, or I'm sorry, 2 minutes, take the 10 seconds it takes you to write out the division part before you do your flip. So that way you don't accidentally write the wrong things down. So easy to make a dumb mistake as you're doing this. Not too terrible. I have one more of those. You do this one. Again, we walked through a more complicated one. I'm working backwards to a little bit of an easier one. Just for argument's sake, since it's x over 5 plus 4, what's the 4 over? Same thing here. What's the 8 over? Take a second, figure it out. Let's see. Do I need to multiply out denominators? Am I wrong if I do it? No, it's just, you don't need to. There's no real reason to go and multiply out denominators. Another thing is that by not multiplying out denominators, you can tell me where my vertical asymptote is. Vertical asymptote. What's the vertical asymptote? The zero of the number. What's the zero of the denominator there? -1/8, right? Okay. The 5 is just a scalar of it. It's just quicker to do that. Questions? I think I don't know if I posted it or not. I don't think I did. It's in line 5. I know the PDF is up. Yeah, I have some in the back. I got spares for people that were missing out. Yeah, if you guys weren't here on Tuesday, I've got some hard copies of the founder review packet. Mr. Nelson, in that green folder on my desk, did you grab these one? Grab that. Pass it around for me. So it's in section. And like I said, they can get a little bit more complicated. We'll worry about that stuff tomorrow. Because if we do a little bit more of the complicated ones tomorrow, it'll make working, not 9.6, I'm sorry, 9.5. I did that first hour or two. So, like I said, we'll do a couple more of those more complicated ones tomorrow. And then we'll talk about how that will help us when we get into solving equations. That's what we want Friday. Coolio? Excellent.